requirement. Hey, we're on Coffee Compiler Club here today to talk about solar panels and battery installation, or compilers and register allocation. I don't care. Um, in fact, I can put my self view on. Everyone's being recorded. We're all going to be up on YouTube within a few hours. Um, Open for questions. I'm going to finish the construction for Levo's question here. I have two solar panels, and I'm trying to get a house battery. So the next time PG&E cuts the power up in the mountains, I can live off of my battery overnight. And I'm talking to the battery people, and they got confused. I told them I had two panels, and I got a call yesterday. What's this funny thing in your yard? Well, that's my second solar panel. Oh, you have two? Like, geez, dude, you're scaring me. Fine. Um, Anyone want to talk about compilers?
Yeah, I want. Oh, someone said something.
Sam, you're like new guy. You want to do 10 seconds of intro and then ask a question?
All right. Can you hear me? All right.
Yeah,
Yeah.
sounds good.
Okay, yeah. So I make this thing called Serenum, which is the concept there is to just redo all the software and hopefully make it better, because then you don't have to inherit bad OS abstractions, for example, and change many things. So as a part of that, I make a compiler. My compiler is currently very slow, so I'm rewriting it to use C of nodes, and I'm therefore following the simple C of nodes tutorial.
What language are you rewriting in?
Well, it's a self-hosted, like weird ISO lang that's kind of C-like.
Okay, fine. Is it C-like? So it has malloc and free instead of garbage collection.
Yes, yes.
Okay,
Although it's very sort of arena centric. So actually, I don't think I have implemented a general purpose malloc yet. I mean, there's an allocator in the kernel that does kernel pages stuff,
right,
but otherwise, I mostly just use
right.
bump allocators.
So C of nodes is written in Java, obviously, with garbage collection. So I skipped all that allocation stuff. C2, which is where this thing all started and simple is designed from or built on, um, uses arenas heavily.
Right.
Almost
Yeah.
everything's in an arena.
That's good.
Yeah. So there's a way to do this. Uh, and Simple's not demoing that way. But mostly I make an arena for phases per se. And then you alternate phases and periodically you copy all the live nodes data, whatever, from one arena to the next and reset the other arena. So it's
Right.
bulk garbage collection by double buffered arenas.
Yeah. Yeah, which is very convenient.
Yeah, yeah. And so it runs that's fast enough, especially for smaller compiles. IR size is important if it fits in your L1 or your L2. C2 does a lot of tiny compiles. They actually fit in your L1.
Hmm.
But if you're L2,
Oh, because it's a JIT, right? So you're
yeah,
doing
it's a
small
runtime
chunks of
JIT.
things.
That's
Yeah.
right. There's a bunch of things different because it's a JIT. One of them is I don't pull up other tools on the fly, so there's no linker and there's no back end pieces of this or that. It's just C2 running and his IR. And then when he got code out, he throws it into the main JVM's code cache somewhere. But up until he's got the code to go, it's all sitting in, one of two arenas, and he's flipping back and forth between the arenas periodically.
Yeah. And is the flipping, do you do the flipping because is that an alternative to a free list? Or do you just, I guess you do a lot of sort of cross procedure stuff inlining, so there's no clear lifetimes boundaries?
Um, there are very clear lifetime boundaries. I do a lot of inlining. I don't do any cross method compilation outside of inlining, really. Um, but inlining is a pretty big hammer, covers a lot of ground.
Right. But what I
Um,
mean by that is when you're compiling one
yeah,
procedure and you want to inline somebody else, you have to actually have that guy's IR available, presumably, to stick
I
into your.
I have his source code available and I parse it.
Oh, again.
It's not again. So it's a
Uh,
JIT. So okay.
yeah.
So there's
Oh,
some.
I see. I see.
So you do Java bytecode loading, runs through the
Yeah.
verifier. It's touched probably once for the verifier, and maybe wants for the load step. Then the linker is sort of incremental over data structures internally. This is the Java model of things. So there's class loading, there's linking.
Hmm.
That's just sort of name resolution across other things that have already been loaded. It doesn't actually look at the IR code. Doesn't look at the bytecodes, the linking. When the JIT comes along, the interpreter comes along, he looks at bytecodes, one bytecode at a time. And if you never actually run any code, the interpreter never touches it, and so it never actually hits your caches even. The compiler runs along, says it's time to JIT something. He obviously looks at those bytecodes. He parses them into C of nodes. If he decides he wants to inline, he parses those bytecodes.
I
So
see.
it's not all the source. It's not the Java source. It's this compressed bytecode source. It's pretty dense. So if a method gets inlined 27 times, I parse its bytecodes 27 times. If it's getting
Right.
inline 27 times, it's probably a getter. It's probably really tiny. It's probably
Oh
not.
yeah, for that it certainly makes sense. Yeah.
Yeah.
Oh.
Okay. Now, so that's that lifetime question. Then within a compilation unit, the parser spits out IR like simple does, where the parser itself is relatively dumb. And he just calls peepholes to take care of business. There are a few places in C2 where an early check by the parser will prevent producing a whole lot of nodes that immediately get deleted. And so that's a speed optimization. But generally, parser emits dumb codes. The bytecodes
Yeah.
clean up during peepholes. While they clean up in C2, it's commonly the case that I produce a couple nodes and then undo them, that they immediately die. And so they undo. And
Yes.
so
Yes.
the operator new, operator delete, C++ is smart, looks at this common pattern, and will roll the arena head back if it can get away with it. So he tracks the
Interesting.
last in allocations that were all in a row. And if he sees they've all been deleted, he then unrolls the arena pointer. Because of the nature of Java bytecodes, where you emit these safety checks back to back to back, every bytecode has a safety check, then many safety checks are redundant. They get optimized as soon as you have enough of a safety check to go look in the IR and see that there is a prior identical safety check, and this one is not necessary. And the parser won't do that, but the peepholes will. So the parser will emit an if pointer not null, throw to blah, 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 else pointer dot load. And somewhere on in there, the peepholes say, wait, there's an if test. And it has a not null versus this pointer. And if I run up the immediate dominators, I find another if of the same pointer. And I'm on the false branch. I know it's not null. I can kill the test, blah, blah, blah. And immediately unwinds 3 nodes. So you'll get this 2 steps forward, 1 step back in the arena notion where he allocates and unwinds and allocates and unwinds and allocates and unwinds. And it's
But can you do that out of order?
I do it as I parse bytecodes in the order the parser visits things, which is more or less reverse post order, breadth first or something.
Right, right. The thing I built for myself is the nodes. Yeah, obviously the parser produces lots of nodes, and then I peephole those. And when nodes get killed, they get put on a free list.
Right.
But then it's a very freshly touched free list.
Yes.
So it's a hot thing.
Hot
Yeah.
cache. Yeah. Yeah. And simple probably will go that route because I have a GC and I have hard, strong type safety. So I can't rename memory back to raw and then rename it to some other node type. And the obvious things here just make work lists of nodes and work lists of arrays of nodes. So all the array lists that go in simple, like if I was doing simple for performance,
Yeah.
I would get rid of array list. That's a level of direction. Don't need it. I would just have an array inside the node. And in fact, I probably would have a few node entries for small count, no array in direction, because most nodes have like 3 inputs.
Yeah.
Like
Yeah.
1, 2, 3. Store has 4. Okay, fine.
Yeah, I did something where I allocate the node on my arena, and then I immediately afterwards allocate the arrays, for example, the array of inputs.
Yeah.
And you pick a number for that, and then you reuse that if you reuse the node. And if some future node wants more, you just alloc a new array.
Make a new one.
But that's rare.
C2 does something closer to that. I tried to get the array to get reset, but I mostly try to take the whole thing and unwind it back to raw memory. And C2 does have the same notion of a fixed size, small count of inputs. The outputs, again, the outputs have this funny distribution, one to many. You're zero while you're in the middle of a parser, but it's usually you have one user or two users, and then occasionally have somebody who's got an insane count. And so you want to you can take advantage of that if you want to. I don't think C2 does that one. I don't do the one too many, although I probably should have. I had other fish to fry. Hey, York, why are you not being obvious on my list? I will go mark you later. Fine. Yeah. So the upshot of doing the original question was, what's the lifetime of the arenas in Y2? The upshot is out of the parser, the arena I filled with still has lots of holes that never got used, that got used and unwound and used and unwound that are now dead. Things died after a while.
Mhm.
Every time you have a loop, you have a back edge. Every time the back edge gets its fees stitched, many of the fees are dead immediately, but they were allocated far back in the arena and you can't reclaim the space. So at the end of parsing, I immediately do an arena flip. And that lets me compress the parse arena into the next arena. And that arena flip is the one where I run I do a copy to get everything into it, and then I run the people iteration on it to a fixed point.
Mm.
Generally, that again leaves lots of holes in the arena and compresses things by an interesting amount again. So there's another flip, and now I do loops. The loops do major things that the array is the node, see if nodes is now static for a minute. I do a bunch of loop analysis to discover all my loop bounds. I rewrite a bunch of things to say that you are a loop, you're a counted loop, you have induction variables, blah, blah, blah. And then I start bulk rewriting, cloning, inlining, blah, blah, blah. And I get a whole lot of new code at that point. And entire loop bodies go dead, and entire loop bodies got cloned or unrolled
Mhm.
or whatever. So I do another round of copy to a new arena to get rid of all the dead loop bodies and run the peoples to completion on the next arena. And then you're into like instruction selection. And instruction selection is going to rewrite all the nodes anyhow, because they're going to go from ideal to x86 specific variants.
Right.
So
I
it's
see.
like
Yeah.
5 or 6 arena flips. But the goal of the arena flip is to compress out all the empty space and reclaim. And there's a lot of places, I put them in carefully where there's places where you get a lot of mileage out of that.
Yeah. I currently in mine well, because I'm trying to improve my compile speed, right? So I sort of just do everything. There's a free pass. The way the language is done is that there are special tokens actually that mark out interesting things like structures and procedures, which means you can actually just get them. You get all those in a first batch. And so then by the time you pass any procedure, you know about all the other procedures, all the structures and everything. So you can go right to
Yeah.
completion
So you want
immediately.
performance? Don't touch it twice.
Yeah.
Read it once. And if you come across some name you don't know and it's some future procedure, you have some way to deal where you say, I don't know what this is. So
Well, yeah.
I'll just
So
put a forward reference in and carry on.
in this case, I don't do any inlining. We'll see. I haven't done any inlining before ever.
Oh, I
So,
see. Okay.
but yeah, in this case, you just stick down like a linking flag to say, hey, I want to link
Yeah.
against this guy, and you continue.
Right. Yeah. So the plan for simple is to put function calls in just as you parse and go along. And then while you're doing the iterations, the people iterators, every call node will stop and look and see if he feels like he should inline based on like his loop nesting. I'm in the innermost loop, and or I call a function whose IR is available because it's been parsed as well.
Hmm.
And that IR is of sufficient size or whatever, and whatever heuristics you want to do, he'll then do an inline. Um, that's the strawman plan until it actually happens. But C2 did, I guess C2 did something a little easier, a little stupider. I didn't have any control over that at the time. I had too many other things going on. Somebody else did it. So inlining happens in C2 way early. And C2 basically just parses bytecode, so he sees it invoke. He asks the right questions about the invoke site, class hierarchy, this, that. Oh, okay, I know the target. And do I want to inline it right now? Okay, and then I just mid-parse of this method, I stop and I parse that method, and mid-parse of that one to the next inline, and then you
Yeah.
unwind as you go. But it's all one parse pass, all inlining done all at parse time.
But you need that in Java, right? Because you have all these insanely small methods.
No, you need the inlining in Java because you have insanely small methods, but you don't have to all do it all in parse time. So I'm
Oh,
saying
I see. Right.
simple will do this during the people work list where you get more information. You know something like, hey, this argument is known to be null, and I call a function whose opening line says if null, exit. Well, I'll inline that because the first thing you do is exit, and the rest of the function's dead, and I don't care, right?
Right.
When you say that you will put forward reference if you encounter something that you don't know
Yeah,
yet about it.
I'm doing that now.
So okay, but what would constitute a forward reference? What would happen when that information is available later in the parse?
Okay. So in what happens in simple now is you see something like struct linked list.
Mhm.
I'm defining it open curly inside. Now, linked list has not yet been defined. I've just
Mhm.
declared the name. The parser has declared the name, set it aside. Okay, I'm in the middle of doing a structure declaration. The first
Mhm.
structure up says linked list of the next field. So he sees linked list. He doesn't have a definition for it. So he's like, what is it? So he throws down a name in the type namespace because he found it in the type place. So it has to be a type. He throws down a generic type, the most generic possible type. In this
Mhm.
case, that would be type.top in the lattice. And
Mhm.
he just carries on. And then if you do things with next, and you can't do things with the next guy in a declaration. So at the end of that declaration, he goes back and says, I now have a linked list, and I replace it back in the type mapping, the type hash table, with the declaration. But there are places floating around now that have a pointer to a forward reference for a linked list. So every time I go ask for a type, if I pull it up as a type description and it reads as a unresolved forward reference type, a top, I go look it up in the table and replace it. So
What if? Go ahead.
effectively, I'm doing a union find on the types
Yeah. Okay. I get it. What if
as I
your
find them.
reference? What if your reference function that you don't
Yeah.
have the definition
So
for it?
right in AA right now, what I'm doing for forward references nodes is I put down a forward reference node type, which can only be a function because that's the only thing I'm going to let you forward reference. And
Mm.
then the other things that you might want to do with out of order namings and functions like a C or Java does multiple passes, so you could have forward things, reference backwards things, and
Mhm.
names can show up later. I can handle another way. But the functions, I throw down a forward reference, which basically means this is an unknown function. I don't know what kind of function it is. And you can call it as the function argument into a call.
So at this stage, it will just put so
It's a
Scarlet call
placeholder.
them completers, and
Yeah.
when it will be triggered. That's one. That's what
During
I.
during the parser, when the def shows up, he has
Mhm.
a mapping from a name to a forward reference node
Mhm.
that he will then discover he's got another def for. He puts a definition for the forward reference down.
Oh.
You said something equals function of its factorial, and
Mhm.
factorial was a name that I didn't have in declaration for yet, so I'm carrying on. The middle part, so is even calls out to is odd calls is even. That's a little better example.
Yeah.
So there's an is even is equal to a function ref of blah 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 is odd. Well, I don't know anything about is odd, so I put down a forward ref. You're making a function call, a call where the target of the method is a forward ref. I don't know anything
Okay.
about that call. I can't inline it. I can't do anything with it. It takes some
Mhm.
arguments. It produces a result. I don't know what. Fine.
And
Then you
then
carry on parsing and building nodes. Then he
skip
comes
it.
to is
Okay.
odd is, and you blah 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 blah, and he says is even. Well, I got is even as a
Mhm.
function. I can put that one in. Well, then I finally declare is odd. When I look up the name mapping I have for is odd, I already have a
Okay.
forward reference. Now I have a function.
So
So I go to the
essentially,
forward reference guy.
yeah, essentially it's like the hash. It's a hash map, and when the name you hash it, you see in there is it a forward reference? It's
Yeah,
a say
I
he
make a
say
name mapping for
yeah,
the
it's a
missing guy.
forward. Yeah, it's so he now say for the first time it puts a forward reference, and the
Yeah,
second time say oh, and that is the
here it is.
definition of the.
So you go to the forward reference node, and you
Okay.
do a union find via nodes. The forward reference just replaces himself as an IR graph
Yeah.
people rewrite with the definition.
Oh, oh, okay.
It's literally, it's effectively a union find, but it's literally a peephole that just says, I am a forward reference node. I'm replaced by this definition over here. And the graph rewrite mechanics take care of it from that point on.
Okay. So can it be it has to be a global space if it's an index. So
It doesn't have to be global. It has to be in the same space as so there's a namespace game going on here.
mhm.
So it's in the first use can be in a nested scope, but the declaration has to appear in some outer scope.
Yeah.
So when I exit a scope, if I had an open pending forward reference that I don't know about, I declare it wasn't in this scope, it had to be in the next outer scope.
Oh,
So
oh.
I promote it to the next outer scope as an I don't know yet.
Like every scope declares it didn't it
Yeah,
didn't
it
find
saw
it.
but didn't understand. The scope just
Yeah.
hands it out to the next outer scope. It
Uh,
must have been going to be defined in this next outer scope until it finally gets defined.
Okay. Oh, okay.
So
Good.
if and exactly when I do like is even is odd, we should do this in a Google Docs, but that happens immediately in is even is odd just directly. Let me find the share. Let me find the Google Docs. Let me bring it up. Da 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 da. Is even is equal to a function where if x is true, see if x is false, it must be zero, so it's even. But if it's true, I'm going to ask the question of is odd x minus one. So while I'm parsing along in here, when I go inside the function scope. So is even is an open unknown declaration. I don't do anything with it. I just hang on to the word is even, and I'm about to declare it. They carry on. I see a function, I parse the function. I'm already in a scope, in the function scope. I see
Yep.
is odd. I don't yet know what it is. So I get a forward reference in the function scope of the moment. Maybe it shows up inside this function scope. If somebody down in here said is odd is equal to, and some function, I'm gonna do something with it. But that's not what's gonna happen here, obviously. But the parser didn't know that. So he just says, when I exit this function scope, he says, wait, I never found out what is odd is. So I'm going to promote it and say it must have happened in the next outer scope. Is odd. And in fact, it is. So now it's up in the next outer scope. And he finds it and he does the thing.
Mhm.
And I guess this is probably, true or whatever. Is even is, oh no, if you're, let's see here. If X question mark, boy, I got this all messed up here. If you're true, if you're false, you are even. There you go. How about that? It's all true and false if you'd rather. Something like that. And I'm doing this test is unequal to zero because that's my defaults for these things, but whatever. Anyhow, the nature here is that at the time the parser sees this is odd, he doesn't know anything about it. He doesn't know what the future holds. He just declares a forward reference.
So if I try to call the function between, I get a compiler error,
No, you get
I
another call
get
to is
hoisting.
I. Now you get another call to is I. You get another who is odd of 17. You get another forward reference call. So functions in what will be simple and in AA are allowed to be declared out of order. In fact, pretty much everything's allowed to be declared out of order with a similar mechanism for
Right.
do
So you
about
could imagine a rule that says I'm going to do hoisting. If I get to this call to is even, but I can't call it because there's a forward reference somewhere, that I just keep reading to the bottom of the file in the hopes that I find something.
Yeah, that's basically what it is. Like here, I've declared right here. I would say you have an error at this time because you can't call foo, but only if in a REPL. In a parse of this function body, I would stop and say, okay, I got to go on. Actually, you're right. At this point, I declare you
But that's
an error. Yeah,
my thought is I can throw an error when I get to this moment,
yeah,
or I can give the developer the benefit of the doubt and say, hey, I have a call that I can't execute because
Right.
there's this forward reference.
Right.
I'm just going to keep moving forward compiling until either the forward reference resolves itself or I run out of stuff to compile.
Doesn't resolve itself politely. Foo is some result that defines is odd. Is odd is a function of one of other several things, or is
Right.
odd
So
is
like Python doesn't do that. If I call something that's got a forward reference in it, it just dies right then. It doesn't matter if on the next line the forward reference would have been dissolved.
right.
Very top down.
I'm agreeing with Python because I don't know how to handle this. So the REPL, as a REPL, the REPL's at this point, and the future is unknown yet. What comes next? So he's at foo. What do I do?
I guess my question is, why is that harder than an open parentheses? If I have an open parentheses, I just have to keep compiling until I get to the balancing close parentheses. I can't execute code as I go.
So in the curlies are declared to be delayed, function body. I just parse to the end. There's no execution. In a REPL, so assuming I'm in a REPL, when I say is even equals, he wants to execute the right-hand side to get a value, assign it to is even. Well, the execution of a constant like 17 is just parse the 17. You have it. The execution of a function constant, same thing. I parse it. I have a function constant. I'm done.
Can you zoom a little bit in the docs?
Yeah. Good enough.
Yeah.
So the curlies declare this whole thing as a constant from the program semantics point of view. This is just a fancy constant. Like 17 or pi, it's just a constant. And in fact, when I would do code gen, it'll be the address of the function that eventually gets compiled to. It'll be a number, hex 1, 2, 3, 4, 5, whatever the binary address in your code execution space is. So that's a constant. However complicated it looks, it's still just a constant. So when I come down to the next line where it says foo is even, open, close paren, that's an application. That's a function call. I actually have to execute it. Well, I can look up is even and say, I have a function that I've parsed and I know what a function is. I could execute that and I begin executing. And as long as I take the is, the true side out of there, the test and the true side, I can reduce I just did browser zoom. I can reduce my browser zoom and go to document zoom, and then whoever's editing the docs can mess with the zoom settings if you would rather. I don't care. But as soon as you hit the is odd, I have to say you're executing a forward reference. I'm dead. So I can make this lazy as much as you like, but if you ever execute is odd, I claim death because I need foo before I can begin parsing the next instruction, because the very next instruction tests the value of foo. So yeah, we can make this lazy. A REPL can make this lazy. In fact, REPL probably should make it lazy. I think that's fair. And if you define is odd and then you start calling it, if there's a JIT involved, you probably have to re-JIT is even.
Yeah, I just like any decisions that can make the REPL behavior and the ahead of time compile behavior
closer
have fewer differences.
Yeah, in the land of Java, this would also work, although the is odd forward reference has to be done through a class indirection. But you can make references to classes that are loaded but not linked, and if you never execute them, they never link even. If you do, like the C2 will JIT that, and he'll just deop to the interpreter, and the interpreter will then go and say, "Oh, I have to link this class." Wait,
but if it's a class. If it's a class dot something, some function, wouldn't the parsing, wouldn't the resolution be delayed until the class is parsed?
So I have some unknown class foo.
Yeah.
And in Java, he would put a class reference to an unknown class foo, and then he'd be fine with that. And the JIT would be fine with that as long as you never executed that guy. But if you execute it, that bytecode would say, "Oh, invoke whatever off of class foo." I'll go link class foo. And then the interpreter has that cutout for that bytecode.
Which is potentially slow. That link moment could be like, go read bytes off disk.
Link could fail. Link could be slow. Link could fail. It could say no such beastie. You have declared a foo. I found a class called foo, and I just stopped there. This is whatever the loading does. The loading is very doesn't look at the bytecode. So the foo has to be mentioned in the class pool. He just validates that there exists a foo,
Hmm.
but he doesn't actually try to link it.
So here we will put the forward reference, but
Yeah.
here when it encounters foo, it has to know all about is even. So how that would work?
Well,
Would it wait for the
yeah, it
for the
waits. It waits until you actually execute that path. So I'm claiming this is, as if Java. This is a forward reference for all intents and purposes to some unknown class foo. The class has to be known to start running the is even code, but you don't have to link it. It doesn't have to be the correct class. And you can shuffle classes around and get them through things here. And I have tests that were breaking JVM security for many, many years that did exactly that. But if you then call this in the interpreter, he interprets this bytecodes. X, test for null, branch to true, fine. Test for null, branch to true, fine. 1,000,000,000 times in a row. The JIT kicks in. Test for null, true, fine. Somebody fails this test. The JIT says, "Oh, I never compiled this. Because I don't have class. It's not even fucking linked. I'm not going to compile it. I just de-up to the interpreter. Or the interpreter says, "Oh, I'm going to run this bytecode." The bytecode says, "Hey, this class is not linked. Don't link it." Then you're off into the VM. The VM does a link job. The VM might fail here.
Yeah, but here the interesting thing is that when you have a clear separation for the source translation and typing on one hand and execution on the other hand, how would that complicate things when you're type checking, parsing, and linking at the same time in one?
Yeah, right. So the verifier, I think if you run the verifier, he'll have to link it. You could still fail another step after linking here. Like you don't have to run the verifier. If you run the verifier, he might link it. I'm trying to remember now. It's been a while. I knew these were all independent steps. And when I first started the JVM, people routinely didn't want to pay the verification cost, especially for local files that they had control over and knew would link and didn't want to waste the time. So I always saw a lot of things that wouldn't pass the linker, wouldn't pass the verifier, and people were not running the verifier. So I essentially in C2 had a verification step myself. Um,
So here for a type, like in
yeah,
simple NA, here for a type it will put top. So
right.
the Java case is more easier because the code is already bytecode and typed, so it knows it.
Right. The verify would claim that the return value is odd is compatible with the either side of the stack there, the Java stack, which is usually a Boolean. So the return type of is odd has to be a Boolean. Or the verifier would verify that. Beyond
Just curious, how long did the verifier take?
Oh, it wasn't that slow. The first cut was kind of gruesome. Somewhere earlier around, Java 1.3, the verifier became fast enough that I kind of didn't care. But given the rate at which enterprises upgrade levels of Java, there were plenty of people who ran without the verifier for many years thereafter. Followed by they had weird mismatched versions of Java code generated from different Java Cs that had bugs and produced a broken code, or they had hand hacked, or they picked up somebody was working around a known weakness in Java by making bytecodes that were legit but not from Java C, and all kind of weird shit happened.
But the
So
bytecode verifier is fast enough that it was worth compiling to bytecode rather than just saying only ever store source on disk and we'll compile it as we're loading it off disk.
the verifier eventually became plenty fast. Certainly much faster than C2. In fact, I claim much faster than C1, other than it had to touch everything. So, if you ran verifier and then C1, your overheads weren't going to be a whole lot more than just running C1.
I've often wondered if it's worth just sort of abandoning bytecodes and saying, no, we just have the source on disk and we read the source. And
Right. One of my theories on AA and simple is that I can probably get the parsing time down enough that I could just do source on disk. It would be whether or not it compresses better. So this is all about size. You got a few thousand bytes. No one cares. You got a few million bytes, maybe networking, I care. You got a few billion bytes. Yeah, maybe I care. Now,
that's
is
one of
it
the
more
things I've
compressed?
wondered. I recently encountered a language called Jelly that was designed to win code golf competitions.
Well, throw a link out.
Um,
These are
and
always
like
entertaining.
one of the features that they had was that they have compressed strings, where you give it this first byte that tells you it's a compressed string and a second byte that tells you how many bytes the
The
compressed
German
string.
strings thing? There was
Um,
this German strings link. We
and
wonder
then
about.
from there on out, it puts in like the gzip table of the string rather than the string.
No.
And it
Well,
makes the
Oh,
source
that's
code smaller because hello world now only needs the gzip version. And I wonder if you put some of these things into your language, I guess I will phrase it as this. What would you do? What would you add to a language if you wanted the minified version of the thing to be valid source code?
I
And
mean,
rather than compiling to bytecodes, you just compiled to a subset of your own language that was the special instructions and weren't really meant for humans. They were meant for minifiers
oh, I see.
that
Yeah, I
do
don't
things like
know.
compressed
I,
strings. This
I've
isn't a
thought
literal
about
string. This is a gzip string.
I've thought about compressing, bytecode formats a fair amount over the years. When they first came out, there was any amount of screaming and yelling from the academic community about how bad the bytecode format sucks. Like a whole bytecode is reserved for remainder, but remainder is excruciatingly rare operation, and it does not deserve a bytecode. So Huffman encoding, get way tighter encodings. Fine. There are other encodings I can imagine now that are way tighter than bytecodes. Is that tighter than minified string where all the big names are shrunk to one letter names and you have the syntax, but it's tight syntax? It's like JavaScript minification. I don't know. One of the goals of bytecodes was that the cost to load them was covered the cost to verify them and even emit easy execution. So like there's a version of bytecodes, not the Java bytecodes. There's a version of bytecodes where they come pre-register allocated for 8, 16, 32, and 64 register machines in their encodings directly. And the act of loading them can be converted, like the speed at which you load them into L1 cache is the speed at which you can convert it to machine code that's pre-register allocated for a small register machine. And then you're immediately executing, stage 0 JITted code or stage 1 JITted code. So pretty lightweight, easy JITted code. And
I'm still trying to remember, but I remember trying to do bytecode versus source code, and it ended up being that whichever was smaller was actually faster
yeah, it's all
because
about cache misses.
yeah, well, I guess that could be part of it, but one of the problems was instead of having optional, I just put like 0 in place,
Yeah,
and that would
yeah,
be like 4 bytes, and then
right.
it got to the point where it was just faster to Lex and then parse. And this was also when I was doing my C sharp prototype. Actually, no, that my C sharp prototype was after, but yeah,
I will
it was
certainly never Lex first because the act of Lexing means you swept over the source code and then you had to sweep over it again. And you only want to sweep over it once.
earlier you mentioned don't touch data twice, and I touched data twice quite a few times,
Yeah,
like different types of data twice
yeah,
outside of the type system.
right.
But
That costs you. That's
But
this.
Lexing doesn't have to be twice operation. It has to be on demand.
You can
Just
do it
give
on
me
demand.
next token.
Yes.
Yeah.
People say Lexing, and then I see them do a full pass to Lex, and then a full pass.
No,
No, you
no,
Lex
no,
on
no,
demand.
no.
Yes. And simple is Lexing on demand. And I didn't want a Lexer. And Debian was like, no, we must have a Lexer because everybody does a Lexer. No, not everyone does a Lexer. I never did a Lexer. Okay, fine,
Mm,
we'll have a Lexer. The Lexer is a trivial inline thing that could just totally go away. It's like
mm.
50 lines of utilities
Yes.
that just push the cursor, the parsing cursor forward and back.
Yeah. Yeah.
Yeah,
I believe
It's really become ambiguous when in some situation when you're parsing, you know what you're parsing, but when the Lexer needs the next token, you can say it's either way this or this or this.
Yeah,
So,
right. The trick here is that the recursive descent language is English designed for recursive descent parsing. You already know what the next token has to be one of these several choices, which are all distinguished by the first character. And so
yes.
the Lexer doesn't have to be this generic, I can handle everything case because it doesn't. You don't even bother. You just
Yeah.
say, oh, at this point, I'm expecting an add, subtract, multiply, or divide token, one of these four, and nothing else is syntactically valid. Fine. in
That's
simple.
actually one of the big debates they're having in the large language model community right now is should you learn on the raw bytes or should you lex it into a token stream and then learn on the token stream?
For speed, I say you actually in both cases. So for speed, it's clear you only touch the data once. On the other hand, if I know something right now and then I'm reaching forward into this unknown stream and I know what shape it has to be, why not use that information?
Right. So the argument people have been making for tokenizing is you can have many fewer tokens than you were going to have bytes, which makes the next stage a lot cheaper because there's just a lot less data to work with.
Yes.
The argument against it is you can no longer answer the question, how many R's are in strawberry, because there's no concept of an R.
Yeah, that was pretty funny. One of the reasons why I wanted to touch data twice was because I figured that if I'm doing SIMD in my Lexer, then I might be able to do like to get a win, even though I'm touching data twice. And I believe I touch all the variables twice and then intern them, and then the intern saves me some time later. But
yeah, here is a sample of the grab a token, and it must be one of these. And anywhere I say match, there's going to be a bunch of these. There's this one. Yes. Search. There's one. There's one. Where's a good table? I have a couple of these tables in here. Yeah, and or equal, less, greater. All these are all the same kind of thing.
Do you store backlinks to source code on nodes to give better errors both for yourself and for users later on?
Yeah, I do with AA and not with simple, although at some point I was going to do that with simple too. Yeah. That'll just be like an offset into the source code file. And some collection of nodes will say, I came from the source code. That'll be part of the collection. So once for the collection of nodes, and then in each node, an int, 32-bit int saying, here's the offset.
I can't remember how you handle variables, but do you? I don't remember seeing any string interning. Was that in there?
I do this in AA a lot. I'm not doing it in simple because I'm trying to be like polite Java. So I call string equals instead of string interning. So variables are done in the scope here. Let me go find the scope. But they're done sort of.
Because I remember interning for
scope
for some nodes, but I don't remember for the strings.
Actually, yes. It's actually I broke scope up recently into two parts. One's got the mapping and one has the variables. This guy, used to be a struct of arrays. Now it's an array of structs. And this lives in a local set in a scope. This is like this guy plus a bunch of allocated, no extra data here. It's going to be scope does this guy. So there's just that function, that structure. Go find my scope again. The scope says I have a list of them. You could have a hash table, except that my expectation is the number of variables in a particular scope is small enough that a linear scan will be the hash table. That's to say, you typically in a scope have 5 to 20 variables. And if that's the point, you're still faster linear scanning. If you had 1,000 variables, I should have a hash table here. But this is a data structure. I could swap one for the other, hash table versus whatever. Not an issue. So when I do a lookup, go find lookup in here. He says, go find. Find's going to do the obvious thing. So do far, here it is. Yes. Scan backwards because they're pushed. So you can shadow. So I go backwards. Scan backwards and look. As opposed to a hash table. Linear scan, here it is. Linear scan instead of a hash table, but probably won't matter until the scan typically hits dozens of variables. Yeah, I'd say many dozens. Fine. So it's just a straight up lookup like that. Now, what you didn't see here was that the lookup is nested. There's a stack of scopes. And if you fail on this scope, you go up stack. The prior implementation I had in here had a stack of hash tables. This one has a stack of these arrays. So I still have to scan backwards. The difference here is that this is all of the scopes instead of a stack of hash tables. I literally scan, this is all the scopes all run together. Here's what it says it. In all nested scopes all run together. So instead of a stack of hash tables where you probe each scope going up the hash table, you run a linear scan backwards to find your variable. And you can be shadowed in different scopes and stuff like that. You'll find the correct guy with just one pass there.
I don't have an example off the top of my head, but how do you know if your syntax is not broken? As in, there's some things that will never be reduced because something else would always be taken. Because I remember using a Bison to figure out if I have a reduce conflict.
I have a one character or one token look ahead recursive descent parser. So he doesn't have the question of when do you get a reduction, when you get illegal grammar that way. See, he has a different grammar issues, but that's not one of his. That's not a grammar issue that he has. Let's see if I can find parser here in my reverse history. Maybe one more. Scope, no. One more. Parser. Yeah, parser just does this match and go. Match. If I matched, you were an if node. If you match here, you were an if node. He probably doesn't have a go-to. Does he have a match? So here's the Lexer being useless. It's the match is just go to the Lexer match, but I didn't need to have a Lexer here. I just go to the inline this, but fine. Okay, now GitHub, let me go to Lexer match. Will you do that? Can you do that? I'm just trying to see. This is a thing on GitHub. He won't let me get to the right of the line here, darn it. Anyhow, Lexer's in the same file. Here's the Lexer. Where's your match? But anyhow, match just the obvious thing. It just grabs the next token. Skip white space, blow up if you're going to run off the end, token match, bump and return true. Or if you don't find, return false. Fine. So under recursive descent parser, you don't have the shift reduce problems you get out of an LL1 or LR parser. Your grammars are more limited in how they're defined, but they're fine in a lot of ways. Like I think Python's a known recursive descent parser. There's a lot of them. A lot of languages have them. It's pretty easy to write them.
Is this the style of recursive descent parser you would do if you weren't using Java? Because this feels like the very sort of sprawly kind.
This is the same thing I have done in C. It's structured. So the top level parse does some setup and calls parse block. Parse the whole program. Okay, what's parse block do? This is a standard grammar of open curly, some statements, close curly. So you enter a scope. You're already here with the curly open. You're looking for the closed curly. If you hit end of file, you're going to be broken. And you parse a statement in a loop. Statement. Okay, what's parse statement? Oh, it's one of these things, including a nested block. So I found an open curly, do another block.
Yeah.
So I'm interleaving parsing with semantic analysis. So it's sprawling because it's both interleaved, parse and semantic analysis.
Yeah. I have this. I have like there's a split between you have parse block or parse scope, I call it, and then you do parse parse expression.
So one of the things going on here that's a little different than from most people's parsers is when I bottom out at the semantics and I'm producing IR, I'm producing SSA form directly, and I'm optimizing it also directly, immediately in the parser while parsing. So if I look at like parse expression statement, see if this guy let me do this. Oh, look at that. He says, I'm looking for a type with a declarations or an assignment or an expression or just a use of a name. Let's go down to parse expression here.
Can you zoom in a bit? It's not readable right now.
I can. I switched to, boy, I thought I had, this tab hasn't been inflated then. Let me, is that better?
A little bit more.
A little more.
Thanks. Way better now, thanks.
Okay. So an expression is now I get into nested parse expressions. You go to parse bitwise right here.
Right. But this is the part I mean that is sprawling in that you handle operator precedence by sort of jumping around. There's a different way where you have
Yeah.
an integer you pass down that's saying what is the precedence level
Yeah.
above me, and so they stop early.
I have that going on in AA. I find this format, as long as you have very straightforward precedences, this format is sort of easier to diagnose and debug and write. So as a tutorial, it's just showing you, here's how I do precedence.
Right. Yeah.
Okay. And then these just nest. And obviously they produce IR as they go. Um,
But do you think this one is slower than the one where you pass an integer down?
no, I don't. I think this is, at this stage, it is unimportant whether you do it with passing an integer down or you do it via recursive descent, because all your time should be spent in optimizing the code, code gen, and things coming after that. The parse at this point should turn into relatively a tiny amount of your overall parse time. Now, I know there are, I want to say Adrian, who, the guy's not here now, but he has a very fast parser, and so his cost model is different. He's a one pass. Read a token and emit code, read a token and emit machine code directly, like a one pass guy. He's super fast. And of course does no optimization, and therefore has different parse code gen trade-off issues because he's trying to be so fast. Here I am willing to admit that I'm going to do a bunch of optimization. So I'm going to switch to an IR, and I'm going to operate on the IR for a while, and then I'm going to emit code out of the IR. And because of that, the parser becomes like cheap. So if I look at this and I say I want to do like I want to say a C1 level compiler, which is where you're kind of a little over, no, I'm actually pretty close to C1 level parser with simple, C1 level code generator with simple. I could get to C2 level before too long. There is a sweet spot where you do some stupider things and get out quicker, but still this style parser shouldn't be the overhead. Shouldn't
Yeah,
be.
certainly.
So I don't care, pass an int or not. I'm doing it just drop down to the bottom levels and emit code as you go.
I'm wondering what kind of optimizations you did to make C2 faster, and what parts were the slow parts.
Yeah, so the number one thing is that the IR is kept small. You keep touching the IR over and over and over again, so you must make the IR small. And that's a major design point with C2.
So in this case, you would never do the AND node and OR node and XOR node. You would
No,
have that
totally.
as one node.
So the cost of an AND node is I have to have a virtual function. So C2 has an AND node equivalent. That is an opcode. So if you look at the node and declare what are the fields in a node, you get a vtable. That is your and or not load store opcode. You get a vtable word. Okay, I have a node ID, which in C2 started out as 16 bits. It's now 32. All kinds of people use this, so that one's hard to get rid of. I have a set of inputs. Here there's an indirection to a list of inputs. C2 has some count of inputs directly in line, so there's no indirection and there's a fixed count. And then one of them is instead an array pointer to a larger structure if he has more than so many inputs. He has a length in line as well, which again is limited to like 8 bits because you don't have more than 256 inputs. So he does a bunch of things to shrink his input counts. So simple has a larger structure. So in Java, you have a mark and a class. The mark or the class has your vtable. That is your vtable. That is your, I'm going to add an OR. Then you have the data. So 4 bytes for the node ID. Here I'll have, say it's a 4-byte compressed pointers, 4 bytes to an array. If I wanted to go faster, I would get rid of this indirection. Make it 2 fields and make them contain the first 2 or first 3 inputs of my guy. Same for your outputs. The common scenario is 1 too many. And I would optimize for 1 or 2 and then do something about many. You want a type thing, that's going to be a pointer. Now I am running low on extra fields. Function, function, function. None of these have any data in them. Function, function, function. So if you're looking at the size of the guy who I'm looking at here, all function, function, function. He's got mark, class, node ID, some inputs, some outputs, but these are a couple more words. So I'm like 8 to 10 words. Type is another one, somewhere around 12 words, and I'm done. Keeping it that small, that's your speed. Here is a debug flag. Oh, it's static Boolean. I'm okay throwing in debug info on debug builds. That happens all the time. I think that might just be it. It's got to be dependencies, got to be in here. So add dependencies came along late in life here. I haven't decided if it's more, C2 didn't do add dependencies this way and had a really hard time doing correct dependency analysis for always running the work list to a fixed point every time. And occasionally you would miss things because it was hard to get correct. In Exchange, you didn't have this field. So I add a field. Is it worth it? It certainly simplifies the engineering in Simple a lot. Simple's not designed for ultimate speed. There's a trade-off there. You can do without this field. It does make your engineering more complicated. This hash shows up, and C2 probably has a lock bit instead. This is a doubling as a lock bit. Again, the engineering is simpler here. You could shrink that to a bit. I think I'm out of fields then. I think at this point there are no more fields.
How random access is this? Like, would there ever be a situation where switching to a columnar store format for your sea of nodes would actually be more efficient?
Right. So many people ask for the node ID. Every time you do a walk, you test the node ID for a visit bit. The visit bits for visiting a graph are not kept in the node because it's too hard to reuse them efficiently. They're kept in other places. So you use the node ID instead of visit bits. You ask the class word. The JVM asks for the mark. I never ask for the mark. You ask the class word a lot. That's the opcode. You ask for your inputs commonly. You hack your output list kind of commonly. In different phases, I might do different things. Like if I'm doing an optimistic type analysis, I'm running through doing the standard globally optimal, strongly conditional constant propagation. I'll only ask for node ID, inputs, and type, but never outputs, for instance, or the other way around. I only ask for outputs, but not inputs, whatever. I only ask for one of the sets of things and not the other. I think they're probably, I would have to go ask the question, but I suspect they're probably fairly uniformly distributed. Every time a people runs, I ask for the hash. It's typically set after the first go. I look at people rules on large random fuzzer. We only have fuzzer things for large. In Simple, I did the count. Peoples run like 2 times per node. So nodes are only visited like 2.5 times or something on average. Once in the parser to make them, can't dodge that one. And then another visit and it maybe does something. And then you get another visit some of the time because you did something on the last one. And so something happened again. They're not touched.
So it sounds like columnar compression you would definitely lose.
Yeah, I'm not thinking you win. It's a good experiment to run. I'm not running it right now. It's an interesting question. I don't know, but yeah, it's not an obvious win. How about that? So, the scope node value thing, I started with an array of structs. I'm sorry, a struct of arrays because it's just easier. I need a thing. I make an array of them. I need a collection of things. I make an array of them. I need a second thing and then I'll make another collection. I mean, a third thing. Now I have 3 arrays, twitch, twitch. Every time I touch one, I have to touch all 3. Every time I resize one, I have to resize all 3. Twitch, twitch. Maybe, maybe not. All right, 4 things. Give it up. Book modes. Array of structs now. So those things happen sort of. I've been through that on Simple already. The struct of arrays versus array of structs. This data structure, which has 4 fields in it, had started life as 1 entry for like names, or be 2 entries, names to types. Oh, 1 entry for hash tables for names to types in the hash table. And then eventually I needed the other thing, the index, and eventually I needed the final. And at some point it was like, blah, 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 blah. Okay, flip formats. Life got a lot simpler. It's actually probably a lot faster too for this particular instance. Having cleaned this up and getting to the end of, if I get to the end of Simple's lifetime, it's all cleaned up and we're interested in performance, I'll bet you speed will first come from getting rid of the node indirections on the inputs here. Getting rid of this node indirection will be the first step for speed. The next step for speed will be recycling node arrays and output arrays for nodes and input arrays for nodes on deleted nodes and cut down your total memory consumption. This is the same thing. I actually did this 20 years ago with C2. It's all about, cache misses. It's all about your memory footprint. Now, the sites have all grown big. So, you have way more cache than you did before, sure. But you want speed, keep your IR small. Total volume
Yeah,
of
that's
IR
an
kind of everything.
interesting game with simple in that there are no million line simple code bases.
I don't have any good speed tests. All I can do is ask the verifier. I can get a million line program out of the verifier, but he makes really crappy code. And the crappy code is blatantly dead from the start in a lot of places. So the parser just like, I'm in the middle of parsing dead code. And he doesn't take the shortcut, but he could. He could say, I'm parsing dead code, so I might as well just do token parsing until I get to the not dead, the balancing paren on this, and then I can start parsing for real. So the verifier is like, not verifier, the fuzzer is like, I'd love to have better code out of the fuzzer, but so many hours in a day. And the fuzzer is wonderful for producing bad test cases, so that's great. But I don't have any big things. The biggest one I got is brainfuck.
I mean, that's what the programming language professor at Georgia Tech used to say, was that the best fuzzers are undergrads.
It probably.
That
I'm
he
okay
used to
with
assign undergrads assignments in all these experimental languages. And you would get 82 kids that all attempted to use your syntax.
right, and they attempted without
And
knowing, and so they got
they
horrible.
tended to find things that passed the tests you gave them in ways you did not anticipate that the students would pass the tests you gave them.
Yes. No, here. Where am I going here?
Wow, you managed to give me an answer that only works if the input is mod 3. How did I not notice that all my test cases had an input mod 3?
Yes, well, the fuzzer handed me a lot of things that looked stupid and broke me anyhow, and I stared at them like, how did I not test this? Oh, So here's the new brainfuck. Different things. I use var. I have multiple variables in a line. I have plus plus in here now. Data plus plus. Put plus plus in here so I can shrink things. So it shrank a lot over the other guy, but this is my biggest program. That's it. That's the whole of brainfuck. And it takes this program, this brainfuck program here, and compiles it. And it prints hello world. And he verifies that he gets hello world out at the end of the program. And down here, cert equals hello world, evaluator evaluate produces hello world. But this is not a very big program. Of course, I have no functions, so you can't get super big. And I want to get to having functions, so you can get super big. From functions, you can get libraries. And then from libraries, you might try something bigger and then becomes, oh, you
Right
solve
now is the
those.
only code generation that you target JVM bytecode?
No, the evaluator. It's the only output is the CF nodes IR, the simple nodes. The evaluator eats them directly. So I have another call from other people. Robert here badly wants me to go ahead and get register allocation. And I did some thinking on register allocation the last couple of days anyhow. And I'm busy doing other things, but I can talk about register allocation. But I mean, I can register allocate this, and then I can do code emission for like an x86.
What chapter was evaluator introduced? I don't remember seeing
Like
that.
12 or 15, 14? That's a good question. I know it came earlier than here. I'm going to not use GitHub grep. I'm going to use Emacs grep here. I'll tell you in a second.
Okay, I probably just haven't got to it because I just like stopped and then
Fast
did a little
Java
bit
comp
and then stopped.
evaluator.
Yeah, I will say code generation was the place where I was most disappointed in my compilers class at Georgia Tech
Yeah. Yes.
because we did all this focus on optimizations in the middle, and then our code generation was like, we're going to only ever generate these 16 instructions.
Um,
Redeem it now. Can we go into code generation?
I'll do a better job of code generation. No, chapter 10. An early attempt in 8 and 9 was run. I think by chapter 10 it was pretty stable. Chapter 10. It's in the test, by the way. It's not in source. It's not in source. It's not in main. It's in test. Evaluator. Evaluator.java. Here you go. It's an evaluator. Find, start, eval, long, div, load. So it takes objects and produces obs from objects. It's like a really gruesome evaluator. every value is a capital O object. I think there's an object class which has just a record. Here it is, a record, which consists of something, I don't know, type struct O for objects and his fields, which are just capital O objects again. It's like completely dumb. No using any intelligent things. Like there's all kinds of good information in the sea of nodes and just doesn't do it. Casts everything in and out of object and evaluates. And so that's actually kind of slick. It means I don't think about the evaluator when I add a new node type in the language. I don't have to hardly do anything to the evaluator. It just up and does something stupid, reasonable. So it's not fast.
Oh, you know what? This seems to be inside your test case, and I didn't really look at the test for
Yeah,
the
yeah, that's what I'm saying.
evaluator and
Yeah,
other
it came in the
things.
test directory. But somewhere around in here, we started saying things where you had the evaluator in here. Let's see if I can find one in here. Oh, wow, the evaluator's in here, but none of the chapter 10 tests talk to the evaluator? No way. I had a bunch of them. Why I'm not seeing evaluator in here.
Evaluator is such a small file. Scheduling, that's much larger, and I haven't looked through it, so I don't know exactly what it does.
But I
You mean the global code motion by scheduling?
main. Go back
It's
to
whatever that's in the test directory.
there is a
I
global
see.
code motion. It's not in the test directory. There is a schedule thing, which is so the evaluator needs a schedule. So there's global code motion, which is my official version of it. The evaluator has a half of global code motion done sort of blindly on everything in order to allow the sea of nodes to be evaluatable by his simple trick. He reads the actual IR directly without any placement information. He needs some placement information. So that's the complaint he's working through or whatever. That's the reason he does his own thing. So here's a lot of uses of evaluator. He just asks a question. Is that time in here?
FYI, Aaron, I'm thinking about Go Bananas.
You thinking about what now?
I didn't follow that. Can you say it again?
Is that a JI reference?
Yes, it is. Go
Yeah.
Bananas. Aaron showed it to me.
Oh, yes.
Yeah.
The JI compiler gives you arbitrary execution at compile time. So he likes to play music and render visualizations of what the
Wait,
compiler's doing.
and it's for a C-like language.
Yeah.
I mean, I don't know how to define C-like, but it certainly sees itself as competing with C++, not with Python.
I mean, AA is going to allow that. I could probably get there with simple. It's a convenient thing. Once you get a large enough certain scale, it's certainly convenient. I certainly have done games in my youth where I did compile time evaluation of all kinds of interesting things to shortcut stuff. Here I was just showing the evaluator at work looking at the prime number guy, and the answer is a list of primes, and I call the evaluator, give me all the primes below 20, and I get back an array of ints. That looks kind of ugly, but an array in Simple's typing system is just a struct that has a length field called length. That's length of type int. An array, actually, really an array of contains ints. And then I pull out the field 0, that's your length, that's the number of primes. And then I make my own number of primes and I walk and I compare from this object at his fields, get the +1 because 0 is the length. So get the capital O object, it must be a long, cast it lowercase long, and then it's a prime. So anyhow, the evaluator, in fact, runs this prime number evaluator here and gives me prime numbers with a classic sieve of Arathes's things. The one in chapter 17 test is a little easier because it can use plus plus and a couple other shortcuts and bars and things. But there you go. So there's an evaluator. It's in the test directory. It runs the nodes. I don't have a code gen at this point, and I wasn't going to do it until I got functions done. But then I was going to do code gen. And Lebo bailed. Okay. What else? Well, what am I doing here?
I was wondering if you could talk a little bit about the strategy for by value structs you recommend, or yeah, that you recommended with the
Oh,
hooking it up to name lookup.
yeah. In the case of uh, sort of simple, which just has really trivial structs, it's just a namespace. You could just name include your way out of it. You just take the struct name, prepend it to the field name, and declare it a flat namespace. When you pass by value into a function call, for instance, you would just pass all the fields until you ran out of registers, and then you spill to the stack. So
Yeah, it just seems like it would be a little bit hairy in terms of parsing or sort of giving good errors or language semantics.
well,
Like
no,
for
that's
example,
this is unrelated to the parser. This is implementation in the IR. And that turns into implementation in the code and the JITting code. The parser should look at a struct. You declared it by value,
yeah.
however that was done, but he parses a struct. If the parser has a parser error message, he's at the source code level. It gives you an error message from the source code. It has nothing to do with the implementation on the back end.
Right, but if you're doing both at the same time, they end up being a bit related, maybe.
No, the parser should be able to tell them apart. He has to be able to tell them apart
Well,
because they have different allowed semantic operations you can do on them.
can
He has to
you
spit out
elaborate?
different IR. So the
Oh,
parser
depending on
knows,
what you do in the source code, do you mean?
yeah, yeah. If you can't tell, if I have a reference in the source code at the source code level, just syntax sugar only, syntax only. I have a name. Oh, I got this name called struct S. Is it by reference or by value? If the parser can't tell and you pass it into a function, should he pass a pointer or an exploited instruction? He has to admit that right then and there. He needs the semantic knowledge. He
Oh,
must
yes,
know.
yes.
Okay, so the
Yeah,
parser must know he's got a pointer or an exploitable struct or value
yes.
struct. Okay. Because he knows, he can emit an error message that says the appropriate thing.
Yeah. But so, for example, if so I've passed an expression that contains, for example, a function call that returned me a struct.
Mm-hmm.
And now I want to do a member access on the struct that was returned.
Right.
It feels, I mean, I bet you could solve this. It just feels like you have to
Parser,
add sort of,
the parser must know if that struct is going to return a byte value or a pointer. Or the syntax is ambiguous and you're waiting for a finer grained
well,
analysis to
yeah,
come along later.
you don't have both. Sorry, I'm assuming they're always by value in this situation.
Oh, well then that's not an issue then. I don't understand the problem. You want to write some code in the doc and we'll just share the doc?
Yeah, I guess, yeah.
Oh, I'm on here. That's what happened. Browser land. Google Docs. Here. Blank code block.
All right, let me open that. It could be that I am confused or like intermingling my concepts too much.
Yeah.
But say I have, we'll do the struct S thing. Whoops. That contains, whoop,
Yes, it's
tab
not a code
doesn't,
editor. No, it's not a code
yeah,
editor. It's Google Docs. Like think,
yeah,
Notepad minus minus.
whatever. Yes,
Right. You
exactly. Minus.
don't want it and
I
okay.
am continuously shocked that they have not added a code block widget.
Code reviews everywhere would immediately leap upon such a thing, right? This seems so obvious.
Like the ability to just say, this block is code, the language is whatever.
Right.
Doesn't it support Markdown nowadays? I thought they just had it recently, well, a few months ago, Markdown to
They
Google
might,
Docs.
but even if you put Markdown for code, which we're trying that. We just have a mono space block, right, to cut and paste in. And you can get code coloring if you add an extension to go get code coloring. So
Right.
procedure returns an S. You're claiming it's all by value. Yeah. Well, what is the question here? What is
Yeah,
your
I guess maybe so the way I am currently handling this is that I put a type annotation on my sea of nodes node thing,
Yes, I have a
right?
type annotation on my sea of nodes. It's called underbar type is the field.
Yes, and so, but presumably then, well, so the way I'm currently doing it is that this when I pass, proc
Yeah.
a call to proc A, we produce
Yeah.
one node that I
Yeah.
return up, and then it seems like you
Yeah.
would have to have this sort of union concept of this is one node that can be broken up into multiple things.
No, okay, no. So if I have a call, I'm expecting it to return me. Yes, but yes, you're correct. You would expect some union type. I have some node in the land that starts life as a struct and now want to explode it and have accessors to break out the parts. And I one of the ways I could do this is to claim that the proc A expression call returns me. That's a good point, actually, now that you've said that.
Do
Because
you
what
do
I
you
would
use the
normally
projection node
yeah, I
types?
would
That's
throw
what I'm
out
doing.
two projections, one for A, one for B. Like a call is going to return me control, memory, and in your case, an A and a B. But memory is going to be one for every alias. I'm going to get a butt ton of projections. But an expression where you have a call wants to return one thing for the parser to deal with.
Yeah.
So in this case, you'd imagine it's returning me some common node type that represents an explodable reference struct, which I could totally go with.
Yeah, so then the question would be if
Hmm.
I have proc B that has we also do multiple return types, right? So
As soon as you do actual multiple return types, you have to decide
yeah,
would
this
it
doesn't
be
work with the sub expression, but
uh-huh,
in
how do you
terms
put
of
right? Yeah.
yeah, in terms of like still when I want to pass proc B and then the thing that comes back is oh yeah, this is a procedure call
Yeah.
that is going to produce. So then to me, if you put the like
Oh,
it produces a
I'm doing
node for each
yeah.
return type semantically.
I'm busy writing in the next block as well. Fine. It's all good. I'm just putting multi-return as a breakout.
Yeah.
Right. Yeah. As soon as you do your subtype thing where you want to say func, if I can say dot A, then I take the obvious one and I use it, use it in a sentence and I lose B and C in my little case
Yeah.
there. Right.
I mean, I would error, but you're erroring in the call frame above in terms of you're doing this live
Yeah.
as you're passing, right?
Yeah. Yeah.
And so it becomes useful to have a node, have that be a unified.
Right. So I think if you're going to
Yeah.
have multi-return,
What makes it func.a and not func.0?
yeah. I in AA I'll allow
It
func dot
looks like
zero as
you're
well.
upping a tuple.
Yeah, in AA, I will allow func.0 as well because I'm getting you the first element out of the return struct, the zeroth element out.
Yeah, I guess maybe the thing that Aaron is missing is that if you use it in a sub expression, if you have if you call a procedure with multiple returns in a sub expression, you
Yeah,
throw away the other return values and just use the first one.
yeah, you could do that. Yeah, you kind of have to, but you could also say I allow, and from the parser's point of view, I allow an S, which I guess the full struct, which I guess would be a node I would put in the language that says I am a struct that has multiple parts internally, which is what my struct is right now. It just I would skip the pointer.
Right. But you would then still fragment it when you store it in a local variable.
Probably. I don't have to. I could keep it as a struct. Like the peepholes would want to break it apart immediately. So it's going to get shattered into individual fields in the peephole analysis no matter what. The parser, who maintains a scope, which has a mapping from a name to a node, wants a node. So
Yeah.
you can imagine him saying, no, I have the a node is the struct, which has itself multiple fields within it. Yeah.
Yeah. Yeah. So the way I was going to do this is you have So like you say, you have the parser has a table in the table for the name. There's a union node, but the union is sort of merging two other smaller nodes. Or is it
Yeah, and
forwarding them?
I would not declare it a unit, I declare it a struct. I mean, just what the structs in simple do right now. They have an input for every field. Now they carry a bunch of alias info that doesn't count if you do by value, but they just have a pointer to the breakdown of the fields. So a simpler version of a struct that doesn't carry alias info just has a set of input nodes for A, B, and C, or however many you have. And when you do a multi-return like that, I would declare you're returning a tuple.
Hmm.
Same thing. It's a struct. The fields are named 0, 1, 2, 3. They're very boring field names. And I get a tuple out as a single struct of this kind of a tuple. And that's what the parser is holding on to. And then from that tuple, I can break it out into my ABCs, or I can call it just the A, or whatever you want to do with the tuple. Same with, so when you have your procedure B returns a multi-return, return a tuple in the parser.
Yeah.
Like syntax, whatever your syntax looks like, I don't care. But in the parser, return a tuple. What's a tuple? Well, a pair. That's a struct with two inputs, one for S, one for int. So if you like, it's a nameless hidden internal struct that no one ever sees because it's just a tuple. But it's strongly typed where the first field is an S, second field's an int. Now that I've got both of those assigned with your assignment, you can then break that apart however you do, or whatever, go to from there. Like
I see.
proc B is return. So I'm going to do a multi-return here where I want to say I have an S. Oh, this is really bad here. Let's see here.
I guess maybe there's a difference between the difference is really if I refer to my declared struct S, do I at the point of invoking the symbol construct this union node maybe that I might want to do something with, or do I construct it before?
So somewhere in here for me, I'm going to call it proc B. It's your proc B above. It's going to return me a pair. The pair is going to be some S and some int type. Does that make sense here so far? So at the time that I invoke proc B, this is known to return me a strongly typed to know to return me, oops, waiting room, Sam, why are you in here twice? Can you hear me? Can you hear me, Sam? Sam got booted and is trying again. I have no sound.
Do you hear me now?
Yeah, I hear you now. You got it.
Yeah, Zoom crashed because, in the year 2024 on
Yes,
Linux,
fine.
things don't work.
Yes.
Right. So what I was going to say is I guess the difference is whether when you invoke the symbol of the struct at that moment create some kind of unified node based on the fragmented parts, or if you keep a unified node around and then
No, it's by value. You have to make a new value. So you make a new struct.
when you
When I say I'm going to make create one of these S structs,
yeah
right? In simple, I'm saying new because I want to have an allocation, but instead I'm just going to say I'm going to have an S. I'm going to give you an A value, A equals 1, and B equals 2, however your syntax is. I just made a new S.
yeah
By
oh
value.
yeah I meant if it's already declared, right? So I have my S.
Yes. Okay.
Right. At the point at which I pass this into a function or something, you could either say, I'm going to, when I invoke my S,
This is
create some kind of union node,
this is
or
no, there's no union node here. I'm passing by value. So
yeah,
the S I got in my S, however that came from, that gets passed to func. You didn't initialize and you're by value, so this is an error program. You want to put an initial value in.
well, yeah, or you have a default. I'm just assuming that it has some previous
Yeah, we'll
value.
go ahead and throw it down. I don't care what, because the point I'm making is that you can't ever have a bare assignment like that, and sometimes at least people would be confused about what's going on. So
Okay,
you
yes.
got a my S, you passed it in by value. Okay. So there's one my S struct in the IR, and it's
Yeah, so you said something along the lines of I at this point define,
yeah,
I
exploded.
know this fancy, yeah, I
And I'm
exploded it.
recanting. I'm taking it back. I'm saying I'm going to let the peepholes explode it. The peepholes will explode that, but the parser does not need to explode it.
Okay, well,
Or it
great.
should
Then
not.
then that sounds completely logical to me.
Okay.
Yeah, so you'd say you have like a union, you create a projection on the union when you do a memory access, then you peephole that and it can
Yeah. Yeah.
look through it to one.
Yeah.
Yeah.
Just like a load of a struct on a pointer looks through the pointer and pulls the field value out. That's a peephole right now. I would have a projection that would just look through and fold away. And now,
Okay.
in fact, write it exactly as that. I have projection nodes. They have idealize ops. They do value propagation, but they don't do idealize this way. I'd make a by value field reference. I make a field reference node. That's what I make it. Make a field reference node. Field A, field B, give me a field name. By field, and that would idealize. If he's up against a known struct, like you do a dot field on where you say proc A dot B above, here the field reference dot B can't collapse because proc A is not
Yes, yeah,
a
exactly.
struct. But in this other case down here where I have a struct, wherever you don't have one, but where I say
Yeah,
my
my
s
s.a.
dot a, that one would collapse.
Right, right. Okay, so then there is actually another case. I want to extend this to by value arrays.
Somebody's trying to
Um,
ask a question, says
oh
what?
yeah,
Is that you?
you can do that.
Yeah, so by value arrays need to be fixed size.
Yeah, yes, they do.
Okay, so then as soon as you make them fixed size, it's a struct under another name.
Yes.
So it's just syntactic
But
sugar and parser, and you're done.
right, but you do need to handle like dynamic lookup.
Yes, but you could do that sort of painfully with the
You throw it to memory and then do a load.
yeah, yeah. I claim, throw in whatever your favorite badness is for take my four things and pick which one as a field. But if you knew that your implementation put the fields in a row, it's all good. So one of the games going here, you say array of zero there, right? So you've decided you have a 4-element array. So imagine you're making a pixel flavored. It has RGB and alpha.
Yeah.
It's got 4
This is the
bytes.
common case.
Right. And you're going to pass them around, and you're going to pass them as a fat 32-bit int into some function. And then you want to go get the arc component out. Well, you're going to have to do shift mask games. That's your access. It's not an array lookup per se. It's not a array base plus index scaled pointer offset. Yeah. Instead, it's a shift lookup. Suppose it's 4 ints, just like you wrote. They're actually ints. They get their own register. You pass it into some function. The function says, give me an array of 0. He has to pick the correct register.
Yeah. Well, so this is what I was thinking is if this index operation is also a projection, since you have a second node on the projection, you can see, this is a constant, therefore I can peephole this to
the constant says, so you want to have a dynamic lookup that will turn into code at runtime that says I passed you in a 1, 2, 3, 4, and then one of the numbers 0 through 3, and also this array, and give me the nth element, and he has to pick one register at runtime. So he has to test. Did you pass me 0? Get RAX. You pass me 1, get RDX. You pass me 2, get RSI. Pass me 3, get RDI, right?
Yeah.
He has to do some horrible breakout code. That should be the uncommon case. Fine. Just emit it as a node in the IR that does an uncommonly horrible thing.
Yeah.
Everywhere you have an array of 0, he constant folds that to, get me RAX, done.
Yeah. I spoke to Yaza about this at some point, I think, and I think he said that so you could, given that, the values can be in register or on the stack, if your register allocator is aware and can ahead of time have moved these values to the stack, then it can be a memory lookup.
Yes, you could, and I wouldn't even bother for the longest time. That cannot be your performance overhead. That cannot be like how much engineering you're going to do to make that work in exchange for what performance benefits you're going to get. I claim no. If I passed you 4 things in registers and I spilled all 4 to the stack so I could do an index lookup, that has to be the slowest possible way to do that.
Right. So you would branch essentially.
Yeah. I would first claim that if you're doing this a lot, you have the wrong model. You need to rethink what the hell you're doing. Like, why did you index each one of these guys? Maybe you're indexing at random. Maybe you're indexing them
Yeah.
all. Well, you should have unrolled that 4-sized loop and have 4 immediate value lookups. And oh, that'll go.
Right. Yes. Yeah.
Okay. So the number one story here is this is an optimization that can be done, but you probably should do many other things first before you do that one.
So you mean you would say that you basically had this either the branch or the throw it to the stack, but you count on that being a rare case, and
Yes.
you actually want this to
I
then
would claim
turn
it's a
into
rare
something
case.
else.
Don't bother. So
Right.
somewhere in here, I have color me. It takes this int pixel thing. It takes a pixel guy, which I know is exploded as a struct into these 4 components. And somewhere in here, I'm doing, P of rand, right? Like, no, don't do that.
Yeah.
This is
Yeah.
bad.
Yeah, no, I have these in my language for completeness and
Yeah,
sort of
right.
logical coherence.
So I claim I should emit code for this. Okay. I'm not going to claim it's fast code, and I'm not going to optimize for it. I'm going to make it correct. And
Yeah.
if you don't do it very often, it'll work fine, and you won't care.
Yeah.
Many language spec things go this route, and Java is just chock full of them. There is a fast path. There is a completeness path. They don't necessarily overlap very often.
Mm.
It's the same with the CPUs and instruction set architecture. So x86 has a lot of instructions that are for backward compatibility, but they just go through microcode.
Right.
So
Yes.
they
exactly.
are correct, but they may cost you hundreds of cycles.
Yes.
So optimize for the common path.
There's what BCD ops and the old school 8087 sine cosine ops, all kinds of weird, crappy things that probably go through microcode and are correct and not fast.
I mean, they're probably
But there's
faster
also an
than the
interesting
original
trade-off
CPU.
in. Sorry, go ahead.
No, that was my only point. You go.
There's a trade-off in language design between should I try to make fast the things that the community is actually doing, or should I encourage the community to do the things that I can actually make fast?
There you go.
Well, the answer is B.
Yeah.
So like one of the things we noticed when Twitter had a JVM team that tried to optimize a whole bunch of the numbers that had sort of been pulled out of thin air in the JVM. How many cycles should we run before we start JITting a thing? And it turns out that most JVM libraries evolved on a JVM that had the arbitrary numbers set to fixed values. So they kind of evolved into playing nice with those values. And when you change it, suddenly a bunch of stuff just doesn't quite fit. And it's like, so maybe the ideal number would have actually been 100 before you start compiling instead of 10,000 before you start compiling.
It varied over time in CPU architecture and software, structures of how fast things could JIT and compile and whatever. I mean, C1 did 100, C2 did 10,000. So there were these 2 different numbers. And boy, oh boy, they both worked out pretty well. Now you could argue that they worked out well because that's what you got handed, so you work with it. Or they worked out well because 10,000 just happens to be a number that is validly correct for the last 20 years of CPU architectures,
Right. I think the answer was that it was close enough.
Close enough. That's right.
And it certainly evolved different software than what V8 did, which was their first tier compiler kicks in the 3rd time you execute a piece of code.
Ooh, wow. Maybe you could make it. Well, that's pretty quick. You know what? That goes into run once versus not. Like there is all this stuff in Java where many things run once and never again. And you absolutely want to make no code for it. So having it start at 3 and not 1 covers that case. 3 is pretty low, so you better be pretty cheap. But
there's an enormous amount of code that literally runs once.
there's an enormous amount of code that runs once, and you shall do nothing except the best possible interpreter. So the hotspot interpreter actually spent a lot of time and energy to get the interpreter to run pretty damn well. It's a for an interpreter, it's pretty quick. Fine. And given that the bytecodes are not like I said, there's a better version of bytecodes out there for which the cost of loading the bytecode in could be turned into the cost to emitting something you could run even on a run once scenario. And it's probably faulting it from the Dcache to the iCache would lose. So you probably don't really want to do that. But at 3 steps, yeah, I can imagine there's a code gen that
Right.
works on 3.
But like, should we be designing our languages in any way differently now that
Yeah.
we're very good at running things on large arrays of data,
There are
and we're not that
things
good at branching?
that you can do that will make code generation hard. And hey, look at JavaScript that we'll never recover from. JavaScript runs sort of perpetually 30%-ish slower than equivalent running Java because they don't have strong typing info in a bunch of places and they have default integers, which are pretty brutal. And yes, they can cheat in a bunch of ways, but they have to keep testing that they didn't break. And the test just adds up. So I claim you can make a language for which you cannot generate efficient code for, and you should be thinking about that. XDC is skirting that edge pretty hard right now. All ints are always capital I integer wrapped ints. That's a big giant loss. Can I lift them to little ints? With some grief and engineering, I can get many of them lifted, but not all of them. And then you suffer the endless allocation costs of having wrapped ints.
Does ecstasy suffer that same problem?
That's what I'm saying. Ecstasy is right on that edge, skirting edge. The current implementation as it's running in the interpreter in spades, it's horrific. The JITted version where I'm emitting Java code and then compiling Java to bytecodes can recover some interesting amount of that. And when it does, it's usually faster, 100x, 1000x faster, enormously faster. So much faster, I can't reasonably measure, like the numbers make no sense. And then other times it just can't do shit and it doesn't matter.
But
So,
that's the worst case because when it's optimized, it's run amazing. But when it's not,
well, so
and you don't know on which scenario
yes.
will you.
Right now it's unreliable and I don't know if I can be reliable in large code. So I'm not there where I can tell I can reliably lift it. But it's clear I'm going to wrap everything at least in one layer, if not two. Every fucking thing on the planet, and that just adds up to death by allocation. So I would claim as a language semantics, honoring thy primitives is a good thing to do if you want performance.
I have in my language gone so far as there are no implicit memory operations. So
Right.
every load or store has I use a percentage sign because it's a bit weird, but it's a post expression a dereference. And so
Hmm.
I can press Control F % and see all the memory operations in the source code, including, oh,
So
here
what
are
happens
the
if you run out
serial
of
dependencies.
registers?
You
Oh, well,
still,
it goes to the stack, but that doesn't count.
yeah. Yes. It does, but it doesn't. I mean, it's a memory op, but it's almost always, yeah, L1 hits. And x86 has accelerators specifically for stack spills on top of that. Yeah, it's L1 maybe
Yeah.
accelerated by an x86 already.
Yeah, plus the main target platform is RISC-V, so I have 32 registers. So it happens, well, you survive actually
Yeah.
pretty long.
The sweet spot for register allocation is around 32. Given if it's humans writing the code, generally
Yeah.
speaking, 32 registers will not spill very much.
Yeah, I have wondered why when we went to 64-bit, we didn't end up with 1024 registers.
Because the hardware is too hard.
Well, they aren't even real anyway. They're just register names, right? You have more than this
Yeah.
on the actual CPU space.
Yeah. But usually 128 to 256-ish. And that's because in a single threaded execution flow of one instruction pointer moving forwards, you can only spit out so many unique registers so often. There's a flow rate which you can produce them. And you just don't need 1,000 because you can't have so many operations floating around because you can't parse and build so many operations. Boy, Sam just got booted again. Well, we could wrap it up here pretty soon.
I wanted to go into a register allocation, but we'll leave it for the next time.
We can do it next time. Yeah,
Yeah.
I think we're well along here. So I will make it clear that I recanted my just explode them all statement. and say, yeah, have a value object that has a struct and let the peepholers exploit them all. And he'll do that just fine.
Mm.
I will say that the by value arrays are pretty convenient. Well, I don't know. They're convenient when copying.
Yeah.
So I do a lot of,
Yeah.
there are slices in my language, array plus length.
Yeah.
And so you can operate through one of those. But then you can also just treat a pointer to an array of fixed size as one of them.
So slices are a different story. I mean, in the sense that it's actually memory and you're doing memory things and they're convenient. You can do syntactic sugar to make them pretty and it's great.
Yeah.
I think that's fine. The by value on arrays means your intent was there was no memory unless it spilled, but ignoring spills, there's no memory involved, which
But if
means,
you've pointed to fixed size array, it's different though.
yeah. And then I say fixed size. Right. So
Yeah.
as soon as you say like 4 byte, it's like network byte buffers, passing ints and doing reversing bytes. It's pixels where I have RGB alphas or whatever. It's a known set of things. And those can all be just fine as structs. I think 2 weeks ago we talked about structs with Alan was here, and I kind of went back and forth and wasn't sure there was a good answer to have structs and pointers in the same syntax and have it be unambiguous which one you're doing.
Oh, no. Yeah, that sounds terrible.
Well, I would like to be able to say that and be useful. I know a bunch of languages try, and then they C be terrible. Yes. Isn't there a non-terrible answer?
Oh, wait, you mean the one where you say, oh, I'm confused what you're suggesting now.
Well, if I pass by value or pass by reference.
Oh, I see. I see.
And
Yeah.
and if I disallow you to, if you declare a value object, I disallow you to pass it by reference anywhere. You can only pass it by value. It's a value object. And is there a syntax for that? And then I have the same struct, but I want to pass it by reference. As soon as I say same struct, I get into this ambiguous situation. If I declare a kind of a struct that is passed by reference, maybe because it's big and I don't want to, it'll kill me to pass by value because of endless copying be death. So there's a pass by reference structure. Okay. And then you do referencing things and all the dot field names, lookups, they all do reference things. As you'd expect, they do loads and stores to memory, and then the peephole tries to lift it. Okay. Then the devalue guy says, hey, I'm going to pass it by value. It has value semantics. I can update a struct by rewriting the whole thing, is make a new value, and this is all reasonable. I pass it by value and blah, blah, blah. Do I use the same syntax? Okay, maybe I do. If I have something that I don't know, it's by value or by reference, is it valid to say is there a reasonable syntax that lets me unambiguously decide I know whether I'm doing a value thing or struct thing? Or should I just disallow that up front? So
yeah, I feel like there's this idea that, oh, if the syntax is similar, then it makes it easy to switch between the two. This is why I like something.
But
something like
the parser wants it unambiguous. Maybe the syntax is similar, but the parser wants it unambiguous.
Yeah, well, I'm thinking of something even as simple as JI has auto dereference. If you do pointer to struct dot something, it will auto dereference that.
Right.
But I find that the way
right. So if I compare a T with a pointer to a pointer to a pointer to a T, like should equals just be like these are different types, or should equals run down to the bottom and see if the things are equal at the bottom?
I mean, yeah, I wouldn't do that, but I guess to me it sort of comes down to it depends, I guess, if you're trying to optimize code written by people who don't care about performance, or if you're building a tool for somebody who's aware and has intent.
Right, exactly. And that is an issue.
In Hilo, they do not have first-class references in the language, and the default semantics are value semantics, but they also have made your copies only to be explicit, and they have parameter passing conventions, basically for let, which is for value, in-out, which is kind of like a hidden reference, sit, which is kind of like a move, and there's also a set, And that's it. And basically, that's pretty, I would say, lightweight syntax, but you do have efficiency. Because if you pass this by value, then it's let. The compiler may still optimize it because you know it's going to be immutable. So you know you're not going to be losing anything by optimizing this. And if you are mutating, then you have in out, then that can be implemented by passing a reference anyway. And so I think that they may be going into something that may be the best of both worlds.
Can I ask, what is the practical reason to have references over just pointers? Is it simply to protect people from doing
Oh,
pointer operations?
when I say that, practically most languages today would have some kind of reference, but I'm almost using this interchangeably. Yes, I mean no pointer arithmetic.
Yeah, I mean something like Rust wants references because it wants to do tons of, well, if you buy into RAII, you want to track like who owns this thing,
So
where's it going.
in the land of the simple compiler sharing, so there are references because I'm sharing all over the place.
Yeah, but I guess you auto free those when they go out of scope.
No. When I'm in the compiler itself, he's making
Yeah.
nodes. The nodes are shared.
Yes, but is there a reason why that couldn't be a pointer to a node?
It is a pointer. It's a reference. Well, I don't know. It's a pointer to node.
So who
Oh, yeah,
owns
but
them
why
and
do we
who
call
frees
them
them?
references?
No pointer
Oh.
arithmetic. It's basically like a pointer, but with less allowed operations that can be screwed up.
Yes. In my head, I think of it as a pointer that, yeah, has less allowed operations on it. Right.
Hmm.
It's just a pointer, and I'm only passing point around and doing pointer.load, pointer.store things. I don't know what other.
And note that in Hilo, if you do pass something by in out, you still put ampersand to indicate that
Right.
it's going to be mutable. So you can see the call sites passing something that can be mutated. So it's not hidden like C++ references. So it doesn't have to be the case that the reference has the same syntax as value on use, like in C++. That's not fundamental.
Yeah, my feeling is that for like part of my language design is also tailored towards sort of new programmers or sort of people getting into programming. And I feel like a lot of people, I mean, a lot of people start on Java and get very, very confused by class reference semantics. Because you learn one thing for ints and then that thing means something very different as soon as it
Yeah, I agree. And it's the same
involves
case with
classes.
Python programmers. One of the most common questions on Stack Overflow is someone passing something like an array or list in Python and then mutating this in a function and then noticing it's mutated outside of the function.
Mm-hmm.
And people generally do find it confusing. I don't think that value semantics are a better default, but it wasn't obvious how to do this, I think, until maybe relatively recently with good optimization. Like you really have to make sure you will not do unnecessary copies. And you can today, but it wasn't
Well,
always obvious.
it depends if you're designing for somebody who knows or not, right?
Well, I
My
would say
sense is that
always. So the Swift programming language, I don't know if you are familiar with this, but they have this nice concept of progressive disclosure, which means that if you have someone who has just spent 1 week on a boot camp, and that's their first introduction to the programming language, they can start using Swift. And then after a few years, they become an expert, and they may want to have access to more fancy features and they can still optimize it. So you progressively disclose the language complexity in a controlled manner, unlike, say, Java, I would say, or C++, when some things are thrown at you all at once. Like public static void, just to say hello world in Java, or references, pointers, R value references, L value references in C++.
All right. I see my academic friends once a year, and they always bitch and moan about how to teach students how languages work. And a lot of them are exactly these issues, and this is why people are not terribly fond. No good options, Popular language, you got to teach it. Okay, immediately public static void main.
Or this
Sound
designed
included.
for this progressive disclosure, but that takes some effort.
or you just disclose everything in about 2 hours,
Here,
which
you
should
throw
be
down
possible with C.
Or
Throw
C++,
down your, you did throw down your things.
but
Okay.
then you to say hello world, you have to left shift standard C out by hello world.
Oh, that's C++. That's something
No,
different.
that's even worse. Okay, who asked me a question about expected direct usage on my S1.A?
Yeah, that was
Us,
me.
A.
Okay,
Me.
what did you get your question answered? Did you figure out
Oh, wait, no,
Mm.
sorry.
this right here? I said S1.A, and somebody wrote something after and then erased it.
Yes, it was me. So
Okay.
aren't the other way around? The record has its fields in the register, but
Oh, by
the
value by reference. Oh, you're correct. I'm backwards here.
uh,
I'm trying to do things the wrong way. Yeah, okay,
so
fine.
by register by
Yeah. Oh,
reference becomes a memory load,
it's not
and
a, hang on.
okay,
Yeah, I had struct in my head being a reference and reference being whatever. Okay.
mm,
R for by record, but I want it by reference. I was thinking R for record instead of R for
yeah,
reference.
yeah. And
Yeah.
the first my first question was a convenient syntax to convert one into the other, or it makes sense to do that.
Right. That's what I'm doing right here. This is syntax that says,
Yeah.
and probably I did this backwards as well. If I have it by reference, I'm going to store. So this is backwards. So let me claim I had this backwards.
Yeah.
And you were confused, and that would be sensible because I was confused. So
Yes.
fine. Oops.
Mm.
Get my alignment. Okay, so it's just if I have a record and I want to store it bulk into a reference, I'm going to store all the fields down.
Yeah.
And if I
And
have a reference and I want to bulk put it into a record, I mean a copy from memory of all the fields. And the copy will not be atomic, by the way. That's an interesting extra wrinkle.
And from now on, you can work with the R as a record as
Yeah,
a
you would
byte
just use
value.
R as a record. Yeah, yeah. And that you assume that that's going to be all register math. But in particular, you could change things in the record and it would work as expected without changing the memory state. So something on here says R.A plus plus.
Mm.
Expectation is updates the register,
Mm, mm, mm.
not S.A in memory.
Oh, yeah, but specifically these two are a lot subtle, and it will be confused regularly, I believe.
Well,
So
right.
you
So
have to understand them in details in order to not mess them up.
right. What I'm trying to do here is ask the question, is there a reasonable parser language syntax that I can have these two different notions of what it means to have a collection of things, one by reference, one by value, and have a very similar syntax, but be obvious to the parser which one is being used because he's cogent, and then obvious to the programmer who's reading it which one's getting used.
But
Sorry,
aren't there?
which are the two versions again? I
Well,
missed
one's
it
a
here.
record, which is a collection by value, and one's a struct, which is by reference.
I think you
Something different.
enforce a prefix on the name. That way they're
Yeah. So I
differentiable.
could do this with I want to say what's the right word? User discipline. User could choose his names such that
But
he
you could
knows
also
he's
enforce
talking
it.
about a record or a struct.
No, what some saying is interesting. You for the one you always enforce the name prefix in order to disambiguate. Is that correct, Sam?
Well, yeah, you could do that. Well, I mean, the crude one would be you just
You can also
force
do
them to be named S underscore and R underscore, and so then all the usage sites also have the info. You error if somebody declares the wrong name.
Or only again enforce it on the functions. Because again, you don't have to do it on the type. We can just do it on the function level and just add an explicit keyword for copy. So if you want to have a copy of a struct, then you say copy and then
Okay.
identifier.
I still want the value or the reference version even when I am not passing it as a parameter in and out of a function.
But what do you want it for? I argue that you should do it in whatever you want it for. If you want it for assignment, then add the copy keyword after the assignment, for example. You don't have to decorate it in type. I mean, it's the same argument as volatile keyword in C. Do you really need volatile keyword for C if you do embedded programming? No. because you'd never care about type being volatile. You care about loads being volatile and store being volatile. So you decorate the loads and store as with something that should be not optimized away. So put it on the operation, not put it on the type is what I would ask for.
Yeah, okay. Right. Like the question for like my color me with pixel P, am I passing a pointer to a pixel or am I passing 4 bytes jammed in one register? Because I actually have 5 pixels in a row and I want to pass them in all in registers.
So you have to syntactically disambiguate.
Yeah, in high-low, when you want to pass by in-out, you put an ampersand in front, at the call site in front of
So
the
at the call
argument.
site, I make the choice.
Yeah.
So there's a default. You're always by default by value or by reference. And then
Yeah,
somewhere, like I can't say take the address of and pass a pointer to a pixel because P was a by value just before, and there was no address. There was no address ever. So
Well,
then
then
there's
you have to create an address.
right. So instead, I'm going to say all things when I do this color me P here, all things have an address. I'm going to say struct pixel and it has some fields. This is always an address.
and you can kind of do both. So like Fortran, for example, has reference semantics by default, but that doesn't mean you cannot pass literal integer to a function. You can materialize it on the stack and pass the address to the stack slot. And that
So
works
right,
out
so,
for
so I'm
Fortran.
not counting stack allocation, but I could go there as well. It's now I need a syntax that says I know I have memory, but I want to pass by value. So at the call to pixel, I want to take
That would be, I feel like you just end up reinventing C though,
yeah,
or something
exactly. That's what I'm coming
C-like.
around to. Surely this is C already, and why do I want to do that?
But take a look at what the high-low does, because I really think they have something interesting. They just have
All right.
those 4 different parameter passing conventions, and they don't really overlap.
So
Right.
this is by reference for all.
Yeah, this one I'm doing by well, I'm making pixel. I'm saying the default is you allocate. Because you allocate, you have memory, you have identity. You can ask the question P equals A, and it's identity versus reference semantics.
Mhm.
And if I want to pass it by value, I have to do contents of star P in order to pass by value.
Mm.
And then on the flip side, when I define color, I want to say I'm taking in by value, not by pointer. I need some syntax for that. And this gets into this is what I mean by C. If you do it per operation, all the operations have to go back and forth, and there's still a default that says I made a memory or I didn't. I still want to make a version of Pixel which never touched memory. I need a syntax for the different from the one where I did make one in memory. And then wherever I use it, I have to say take the thing or take the contents of the thing or the pointer to the thing or the address, make an address of the thing that didn't have an address before, whatever. There's something going on here all the time, which is why I don't like doing it per operation. I mean, I hear you, Matt, and I'll look at high-low. I think you've done it before, and I think I looked at it before, but I'll look again. But I'm still like, I'd rather not do it per operation if I can avoid it. Maybe it can't be avoided. Maybe it's a dumb question. I don't know.
I mean, it's either that or you will reinvent C++.
Yeah, I don't want to do that.
It's kind of there are only so many choices.
Yeah, I got it. There's only so many choices, and I don't like C++ either. My putting it on the type was my attempt to dodge it, reinventing C++. And in exchange, I can't tell per operation. I have to go back to the declaration. Was this a memory or not the memory? Except there'd be some operations you could do by value or by reference you can't do by value. There are things you could do. And then I was saying, oh, S arrow A or versus R dot A is your hint that you're getting a load. Sam was saying, hey, I make my loads explicit. Okay. I kind of did an explicit load here.
In high-low, the default is by immutable value. So if you want to mutate it, you have to explicitly copy, and then you write dot copy parent.
Okay.
That's
and
surprisingly uncommon, because if you do want to mutate it, you can still pass by in out, for example.
Couldn't you have a situation where you I don't know, I just feel like I used Jai recently to make a video game with some people, and it has very heavy auto dereferencing, such that I much of the time had no idea if it was by value or it kind of didn't matter for most of the code.
Mhm.
I found that very uncomfortable, but
Yeah.
it was also
Okay.
fine in many ways.
I dislike the C's reference semantics because it was always implemented under the hood as a pointer, and it felt very uncomfortable having you try to cheat me to look like a value but act like a pointer.
Oh, you mean in C++?
C++, C++.
Yeah.
Yes.
Don't you still have to put an arrow down?
Yeah, and I wrote an arrow down on this one down here as an alternative syntax to say it's a load or a store to memory, but memory is involved. Key point here is memory is involved.
Yeah. Well, so Jai just has you do dot member, and then
Right.
if it's a pointer, it will auto dereference that.
Yeah, and I had dot down here just a second ago, just like that, the dot, and I'm like, okay, is there
But then
memory or not?
in Jai, it's not a struct versus a record or something like that. It's just struct or struct pointer, and
Yeah.
you can do dot on both.
Oh, okay. So, but if I pass a struct around without a struct pointer involved, that's not involving memory. It's passed by value.
Yes. Although there's weird stuff in Jai where I think the default, for performance reasons, I think he chose to say, oh, by default, we're going to pass structures by pointer into functions until they are mutated.
Okay.
And so we will then make a copy.
Oh, copy on write?
Yeah, but it's like value semantics, but the backend has a lot of like we optimistically pass by reference until something comes up.
Yeah, and then but if you make a copy on write, who does
Yeah,
the memory allocation? Who does
So
the
in Hilo they decided
I
to
think the
make it
child.
in Hilo they decided to make it explicit, just write dot copy, and they did come from the Swift background which was doing copy on write, and they decided it is so rare that it's not worth to have a performance cliff. Might as well have explicit dot copy.
I see. Yeah, sure. That sounds good to me, honestly. All right, I'm not here right now in simple. I'm going to do a little bit more sugar, and then I'm going to bail and go do functions. And the somebody asked for the bang syntax for let me show you guys. It's getting on, but I'm trying to invert the mutable versus not mutable declarations, and I claim it's getting ugly. And so I was going to throw this out and then ask people to think again. Da, 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 da. So here I am. All these are one-line programs. There's a bang hidden in the middle that says C is mutable because by default everything became immutable. The old default was if I said int a equals something, it is mutable. Now it is immutable. But the test here modifies C here. And again and again. See a lot of bangs, and again 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 and again. Okay, so it's just 100 of these. Now, is this actually an issue? In Brainfuck, I only had to do one of them. But in these other tests, they're just like all over the place. And you get kind of hideous things like, here's my linked list code. Make a struct linked list, carries an I. There's a linked list question mark for the next field. Oh, the next field is mutable. Okay, next fields are expected to be mutable in a linked list because that's how you append the list. Well, that means I have a bang here and I have a bang here, and then I have to bangs and bangs and bangs and bangs, and it kind of looks ugly. So don't have to answer it now. On Coffee Club and in the Discord, on the Discord channel, let's have a discussion. Do we really want to invert the default behavior of mutable and immutable?
By the way, it's also worth looking at this deferred temporary materialization. I don't know what it is that you will end up doing, but it is useful for the value semantics. For example, when you have a function calling a function calling a function and it returns a value, you can directly materialize the returned value at the start frame of the actual outermost callee, and then you just reuse that start frame. So even that's one way of avoiding copies in a specific case of the value semantics when you have a function chain returning something by value.
Okay, that's a performance optimization as opposed to
Yes, but it's a language semantics definition. You had to explicitly write this in the language semantics. In C++, for example, you are not even supposed to have observability. So even if you write destructor and copy constructor that say print something out, I have been copied. Now, by definition, it is not allowed to print I have been copied. So it's guaranteed not to be ever materialized in intermediate way. And it's a language definition thing, because again, it could be observable otherwise. Because
well,
you could
only
have
if you had
if you have debugging statements in the copy constructor.
no, I said if you have a copy constructor.
Yeah, but you are not even allowed to copy to this copy constructor. It has to be.
I would start by saying I'm not having a copy constructor that's getting called by default.
Yeah, that helps too.
That was one of the things I didn't like about C++ as well. I mean, I used it. It wasn't worth it to have a copy constructor. It's one of those. I'm glad somebody experimented with it. I'll not use copy constructors. Not without explicitly. Well, I'll explicitly use them when I want an explicit copy constructor, but I do not want one by default.
Right.
Fine. All right. I'm going to claim victory or defeat. I don't know which one. And say until we meet again. And it was very nice meeting you, Sam. And you're welcome to come every week and pester me about copy constructors and register allocation and everything else.
Sounds great.
Okay.
Have a good weekend.
Yeah. Have a nice weekend. Bye-bye.
Goodbye.
Bye.